We're here to make our mark on the future. To make cities safer and run as efficiently as the human body. Autonomously sensing the world around us so human minds can be free to do what they do best. Create even better ways to make the world a better place. But this isn't a fanciful dream. We have the technology now. Today, we can automatically detect an accident, alert emergency response, and reroute traffic in the blink of an eye. We can connect physical security and video surveillance throughout a city to detect threats and respond immediately. Cars can sense pedestrians and obstacles, brake on their own, and communicate with the vehicles behind them to do the same. The smart city that was once impossible has arrived. This revolution is waiting for no one. It's going full speed into the future. Flir, the future of brilliant cities.
The 21st century will see the advent of smart cities where traffic networks have to run both smoothly and safely. To achieve this goal, MAC has developed a wide range of innovative solutions, with many applications for users, network operators, policymakers, and law enforcement bodies. The software suite developed by MAC provides in real time all relevant data on traffic, its density, speed, or travel times. So if necessary, it's easy to anticipate potential problems and adapt accordingly. They also help to implement and respect environmental measures. Linked to the internet and facilitating the exchange of data, our solutions simplify life and the city for users. And they can also be very useful tools to help in the day-to-day work of law enforcement bodies. Our cloud version makes our solutions life simple for users and operators. With all this accumulated data, public planners also have the most accurate information to make the best decisions, for example, when designing infrastructure. All these solutions and many others can be adapted or combined in different ways, depending on your needs or your budget.
Hello everybody, welcome to the webinar on monitoring and enforcement at the ITS Congress. My name is Injaals de Mul, head of the sales department at the company MAC that, as many of you know, specializes in ITS technology and that is especially known in Belgium for its police and mobility solutions based on Ampere technology, our Ampere ecosystem named MCube. In this webinar, we will keep our finger at the pulse of monitoring and enforcement in Belgium. As you know, monitoring is a source of much mobility data, the lifeblood of most ITS services. As you can see, our mobility patterns are changing. Some mobility trends are accelerated because of the coronavirus, such as the use of bicycles. And some are changing maybe temporarily, such as increased single occupancy of car use or reduced use of public transports. What is clear in a time of change is that there is a demand to accelerate digitalization and to have more real-time data, especially mobility data. Monitoring and enforcement are crucial in this respect. So expect infrastructure-based monitoring to go up, and floating car data and app-based monitoring is clearly going up as well. But it seems more and more concentrated in the hands of what is known as the GAFA, Google, Apple, Facebook, Amazon. This raises the questions how to get to a competitive market of data. Data that is of high quality and that is available to policymakers as well as to the local industry. So, first talk is about ScanCar in Liège that, as you can imagine, generates lots of data. It is presented by Bert de Winter of Rowers Control. Second talk is Data as Enabler of Agile Policies. This is given by Jeroen Brouwers, data specialist of TomTom. And finally, we have a presentation on monitoring and enforcement in the road charging domain by Elisabeth Verbrugge, CEO of Satellite Belgium. At the end, we will draw conclusions from the webinar, and we can use all your help, so please speak up using the chat. So, here we go, starting with Bert.
Bonjour à tous, je me présente Bert de Winter pour la société Rowers. Rowers Control, en tant qu'entreprise innovante sur le marché de produits et services aux professionnels de la route, répond aux enjeux du futur en matière de solutions au stationnement et à la gestion du trafic. La ville de Liège engage depuis cette année 2 véhicules de scanning pour le contrôle du stationnement. 3 points méritent notre attention afin de faire comprendre l'enjeu d'un tel projet, la complexité, le fonctionnement et les shapefiles. En complexité, il y a tout d'abord la connexion avec plusieurs bases de données. Un système de scanning d'office doit interroger des bases de données dans lesquelles sont reprises donc, les droits. À cela se rajoute le grand nombre d'emplacements, toutes zones confondues. Il y a le plan de stationnement, le règlement de stationnement complexe à Liège. Tous ces emplacements-là seront regroupés dans une carte digitale, seront reprises dans une carte digitale. Dernièrement, il y a la coordination avec plusieurs parties prenantes. Effectivement, à Liège, donc, il a fallu rassembler les services de la ville de Liège, la police de Liège et les services de signalisation de la ville de Liège. Il a fallu connecter et intégrer les logiciels du système de scanning, du système de traitement d'observation et de gestion des redevances. Le fonctionnement. Donc, tout débat évidemment avec le scanning. Le véhicule de scanning va scanner en fait toutes les plaques d'immatriculation dans son champ de vision et va stocker les photos. De là, le véhicule va envoyer les données au back-office, la plaque d'immatriculation, la géolocalisation du véhicule scanné, date et heure de cette observation et l'identité du chauffeur du véhicule de scanning. Dans le back-office, la géolocalisation du véhicule scanné sera vérifiée avec les shapefiles. Prochaine étape, on va comparer la plaque avec les différentes bases de données. Le point 5, le back-office va rejeter tous les véhicules pour lesquels on retrouve un droit et va garder les suspects. De là, donc, le back-office va créer la liste de suspects, donc, enfin, toutes les voitures pour lesquelles on n'a pas retrouvé un droit, et à ce moment-là, le back-office demandera à la ScanCar d'envoyer les photos de ces observations. De là, dans le back-office, les observations seront vérifiées et validées. Une liste des contrevenants sera créée et sera exportée de manière automatique, donc automatisée, vers la plateforme qui va gérer les rétributions. Dans ce cas-ci, pour Liège, c'est Inforius, et cela en connexion avec les services financiers de la ville de Liège. Le dernier point qui mérite notre attention ici, c'est les shapefiles. Les shapefiles permettent de déterminer si un véhicule scanné a été retrouvé sur un emplacement régulé et sous quel régime de stationnement. Les shapefiles, en fait, en simplifié, c'est une cartographie digitale dans laquelle des polygones vont représenter les emplacements de stationnement. Et les shapefiles forment carrément la pièce, je dirais, maîtresse du système. C'est l'exactitude, la précision et la complétude des shapefiles qui en déterminera le succès et la rentabilité. Chaque polygone dessiné sera attribué ses propres valeurs, ce qui permet de le faire correspondre aux caractéristiques des zones de stationnement dans lesquelles se trouve l'emplacement. Pour la ville de Liège, on a créé 9 zones. Voilà dans le cadre que vous voyez là. Donc, justement, ce sont les informations sur un polygone. Ici, donc le polygone 550 qui se trouvent dans une red zone. Je vous remercie de votre attention. N'hésitez surtout pas de nous contacter, donc, soit dans le cadre de ce congrès virtuel en posant vos questions dans le chat, soit en visitant notre stand virtuel ou soit en prenant contact en direct. Merci.
Good afternoon, goedemiddag. Welcome to this presentation about data as an enabler for agile cities. In this very brief presentation, I want to give you a quick insight in how you can use data for different purposes, including some COVID studies. Well, first of all, you might remember TomTom from the days we were selling consumer navigation, and we're still doing that. But over time, TomTom has developed into a location technology specialist, and selling consumer navigation apps and devices is just one part of our business, because the majority of data we collect today is coming from our automotive partners. It's coming from our licensing enterprise customers, but we also source data from official sources like Agentschap Wegen en Verkeer, but we even use weather information in order to fuse that into our traffic information. So as TomTom, we collect millions and millions of data sources, which we use to create real-time traffic information, but we also use it for all kinds of interesting statistics. And one of the things that was particularly interesting during this year was our traffic index. So we use the data from everywhere in the world to determine how busy it is in every city. And in this slide, you can see the statistics for Antwerp, Brussels, and Liège. What you see in the statistics is how busy is it compared to midnight. We call this the congestion value or congestion index. And this value is changing over day. And in January, February of this year, things were all normal. So every rush hour, there was a high congestion level in all of these cities. But as you can imagine, when COVID hit, and people were working from home or were not even allowed to go outside, there was a tremendous effect on the congestion level in many cities. And we actually saw this represented in our data right away. And you can actually see interesting statistics country by country from when the congestion really started to reduce and when did it pick up again. And one of the things interesting in this Antwerp example is that right before summer, the congestion levels were back to normal, or actually they were worse than before COVID. And the reason was roadworks, but the data doesn't really directly tell you that. It just tells you the travel time in the city is much higher than what it usually is. And this is one of the interesting statistics that you can get out of using all of that data. But using it for COVID is not the only reason why we use it. We have a platform called the Move platform, and in the Move platform you can make your own queries. And as a municipality, as a consultant, as a transportation company, this can give you really interesting statistics. What I show you here in this slide is an analysis we've done for the city of Breda in the Netherlands. What this image shows you is who from the province of Antwerp is traveling to Breda. And this gives interesting insight because it tells you from what zone there are more trips traversing and what zones are less trips traversing. So when you want to take measures, you have much better information from where people come from and where they go to. Obviously, all of this information is anonymized, but it gives really nice insights and it will help the mayor of Breda to make the right decisions in order to reduce the risk of COVID. Well, this is just one example with origin and destination, but you can use the same data for all kind of route and area analysis, giving you a lot of useful insight in how is congestion, what are the problematic points in my network, where is the speed higher, where is the speed lower. It gives all kind of relative insight that helps you to understand how traffic is behaving. So that's my brief story. If you're interested to test this out, go to move.tomtom.com/register, get in touch with me or check the chat of this Congress to help you further with some more information about this.
I am Elisabeth Verbrugge from Sotelic. For those of you that don't know us, together with our shareholders and suppliers, Systems and Strabag, We have a long-standing experience in traffic management and tolling solutions. In Belgium, more specifically, we are the national and single service provider for truck tolling. And today I would like to talk with you about how we can leverage the learnings and experience from truck tolling when looking forward to distance-based road charging for all vehicles in the future. We all talk about mobility as a service. And at Satellic, we're also thinking about how tolling as a service can be an integral part thereof, because we indeed see our industry as being uniquely positioned to really facilitate a shift to more sustainable mobility models. We can offer solutions and services that support, for example, a tech shift from owning a vehicle to actually using a vehicle. And this can help in creating a mindset change. Instead of thinking, I'm already paying for it, I might just as well use it, we can shift to a thinking, if I want to use this vehicle today, at this moment in time, to drive from this location to location B, is it the best choice for me today? So in this way, technology can support a tech shift in using a mindset change, and as such leading to a modal shift. Having all players play the same game with the same rules can of course also accelerate this. If we're thinking about implementing a similar scheme for all vehicles as already exists today for trucks, this could definitely address some of the known issues in the area of mobility, environment, and infrastructure, including related investments. And this brings me to a key point for the success of any road pricing scheme. Public acceptance is key. Several of the building blocks for that include, of course, having a fair price, having clear and objective criteria for price differentiation. We can be thinking about the vehicle type, emission class, the road you're driving on, the time you're driving, the direction you're driving in. Also linked to this, it's interesting to observe that we're getting more and more accustomed to the concept of a pay-per-use model, also in mobility context. One clear example being car insurances, which are now also being offered on the basis of kilometers driven. There are, of course, also important differences to highlight and specific concerns to be addressed when thinking about passenger car tolling. For example, there's the obvious one, the sheer scale of operations would be vastly different when applying road charging to all vehicles instead of just to heavy goods vehicles. But there's also very specific concerns to be addressed. We're thinking about, for example, social inclusivity. We're thinking about privacy concerns. Those must be addressed at the very beginning of any design phase. And there's also the consumer experience as we know it in mobility and travel that is to be considered. We're very much used to booking and paying any trip, any travel, any transport with just a few clicks on our mobile phone. But here we also see the opportunity for innovation. In truck tolling, traditionally, we've been using separate dedicated hardware devices, onboard units being placed in the trucks. We can now go in the direction of app-based tolling, addressing the specific wishes and needs of every single individual end user. We can have one or more tolling apps which are combined with the hardware device of choice of the end user. It could be a smartphone, it could be the board computer already integrated in a vehicle, or it could even still be a dedicated separate hardware device. Within the T-Systems group to which Satellic belongs, we've already been developing such app-based tolling solutions. And they're not only compatible with the tolling techniques that are already being used in Europe, they also demonstrate the possibility to integrate it in broader mobility and travel solutions. So to summarize, Belgium has already been the frontrunner in Europe by implementing the very first fully EETS-compliant truck tolling scheme, praised by the European Commission as being the model for future tolling in Europe. The technology is now there, and we are ready to support the Belgian region with being the first European country to implement GNSS-based, distance-based road charging for all vehicles. If you have any questions or want to dig a bit deeper in any of the topics we've been discussing, please feel free to reach out to me or ask your questions in the chat. Thank you.